Okay, let's start. Let's start. Take your tutorial. Take your tutorial. Read 2000 A-level question. 2000 relative velocity A-level question. Take it. A-level question. Okay. Now read and start. Okay. Take your time. Water in the straight river bed D flows with uniform velocity u. A man capable of swimming at speed v relative to water swims so that he moves right across the river perpendicular to the bank. Find the time taken t by the man to cross the river. Show the time he take to swim distance d parallel to the bank and upstream and back to starting place. Okay, why should be v greater than u? Now take your time. If you have any doubt, do with me. Here the river, it flows with velocity u. Flows with velocity u. Then velocity of river with respect to earth u. And breadth given simple d. Then velocity of man with respect to river given v. Then velocity of man with respect to earth, he want to move right across the river perpendicular to the bank. Here resultant 1. Now by this data set you better to subject direction known quantity and write relative velocity theorem. ME, MR, RE. Then MRV, REU. Here the set. Okay. Now here take PQ notation. PQ vector, QR vector, PR vector. Then here PQ vector, QR vector, PR vector. Now start sketching velocity triangle. Okay, here we need to sketch circle. Here PQ, velocity u. Then it says that it moves perpendicular to the banks. Therefore, definitely v value greater than u, otherwise the motion will not possible. Then Q center, radius, v circle. We have to explain why v greater than u. So we have to say to move upstream and perpendicular to bank, definitely we have to get v greater than u. Now here PR, here R, here radius v, u, here PR, say R1. Then PR1 by the Pythagorean theorem, v squared minus u square root. Then time to cross the river, so we have to move d distance, d divided by PR1, that means d over v square minus u square root. Here the time taken now. That's the time taken now. Now thereafter he need to move the upstream d displacement and downstream d displacement. Then here upstream 1, R2, then here downstream 1, R3. Then PR2, upstream v minus u, PR3 downstream v plus u. Then displacement d, now here total time t equal d divided by PR2 d divided by PR3. d of PR2 v minus u, d of v plus u, here v minus u, v plus u, d times v plus u, d times v minus u. Then simplify 2 dv divided by v square minus u square root v square. That is it. Okay. Then we have to put that with t. Then substitute this one. Here 2v d over v square minus u square, put root, into v square minus u square root. Then this part we say capital T, 2vt over v square minus u square root. Okay. Then if v greater than u, then only motion happen. V greater than u, only this motion will happen. Otherwise, we get imaginary time. We get imaginary time. Within square root negative mean imaginary. Then only we can get real time. Or otherwise, you can say upstream motion possible for v greater than u. Okay, upstream motion possible for v greater than u. No? That is 2000 A level question. Okay. Then you move to 2001 A level question. 2001 A level question. Read and start. 2001. Take time. (2001), take your time. If you haven't doubt, do with me. A motorboat whose speed u is to intercept a ship which moves with constant velocity u in northwest direction. So, velocity of boat with respect to earth given u kilometers per hour, and velocity of ship with respect to earth given v, that is northwest direction. Here northwest 45 v. So here v given greater than u. Sorry, v less than u. V less than u. Initially, the ship located simple d distance north of the motorboat. North of the motorboat. Here boat, here ship, simple d. So the intention is boat moves to intercept the ship. Then boat moves to intercept the ship. That means relative path will be like this. Velocity of boat with respect to ship will be like this. Then only they meet, no? Then only they meet. Okay? With respect to ship, that has to move due north, no? Then only they meet. Okay? Now, with our data set, we have to think. Here, this contain both magnitude, this contain only direction, this contain both magnitude direction, this contain only magnitude. Then you have to subject direction known quantity. Subject direction known quantity first. Then write relative velocity theorem. Remember, we have to subject direction known quantity. Then other side will be both direction known quantity and magnitude known quantity. Then you better subject direction known quantity. Write relative velocity theorem. BE ES like this. then BE, that is U, ES, opposite direction V, 45 inclination. That is our data set. Now use PQR notation. Here completely known vector take as PQ. Here this is PQ, then surely this will be QR vector, then the resultant will be PR. You identify that standard format first. Okay. Now sketch PQ vector. That is V. Then QR vector U value greater than V. Here P, Q. QR value greater than QR value V, that V, U greater than V. Therefore QR U no, then take center Q, radius U circle, sketch it. Q center, radius U circle. Now here resultant PR that has to move this way. Then P, this will be R. Then here radius U. Then we need to find PR value. We can do that one using Pythagorean. Then here V sine 45, V over root 2. Then here again V cos 45. Here this is cos. Here V sine 45. That is V over root 2. Then consider Pythagorean theorem. Here U, here V over root 2, apply Pythagorean theorem. U squared, V over root 2 square, root, by that you subtract V over root 2 again. Then simplify here 2, that goes to here. 2U square minus V square, root divided by root 2, minus V divided by root 2. Here it is. That is PR. Okay. Then board need to move simple displacement to catch that. Okay. Then we can take time now. Now here the velocity given kilometers per hour, displacement given in hours. Therefore time to catch the board, catch the ship, T equal D divided by PR. That is in hours. D divided by PR mean 2U square minus V square root minus V over root 2, then root 2D, 2U square minus V square root minus V, multiply by conjugate now, 2U square minus V square plus V, 2U square minus V square plus V. Okay. Now further you can simplify now. Then root 2D, 2U squared minus V square plus V. Then denominator difference of 2 squares, 2U square minus V squared minus V squared. Then we can get the value. Then here 2V square, take denominator 2 outside, then U square minus V squared, root 2D, 2U square minus V square root plus V. Here it is. Complete. Okay, then go to 2002 A-level question. 2002. Start. Two 2002 A-level question. First read and start. Okay, 2002. Now here you identify here velocity of man v, velocity of man due east, velocity v. Then wind appears to blow from south. Wind appears to blow from south. So when he doubles his speed, then wind appears to blow southeast, no? Southeast. So now here we have two different cases, same question. Now for both case, we know velocity of wind with respect to earth will be common, no? This is common. Okay, that won't change. Only magnitude of cyclist speed change, then appearing velocity has changed, but wind velocity that won't change. Both cases, no? Now here, this common one you subject common one, subject this. Now let's write relative velocity theorem. Let's write here VWE equal addition of two velocities, here WM ME, here the data set. Now consider first one here and here, that is first set. Now second set, same thing, no? Same thing, here WM 45, here first case. Second case, VWE VWM VME. So here 45 inclination and here 2V. Now here both case, these two same, no? Here these two same. Now addition of these two vector must be same, no? Therefore you can rewrite this one. You write this vector relation. This is equal with here this relation. You identify here there are two cases with common one. Now use PQR notation. Here say PQ, this will be QR, then the resultant will be PR vector. Resultant we shall be right PR. Then different cases, there are two different cases, then PR fixed, that means this won't change. But there are two cases, then definitely we have to change Q value, no? For two cases, resultant PR that won't change. Two cases PR common. Then for two cases, definitely we have to change Q. Otherwise, that won't be different, no? Then here Q1 put. Then here PQ1. Similarly, you get here P won't change. Take here Q2. Then here Q2, this will be R. Likewise, you put PQR notation. Then start sketching PQ1V. Here PQ1V. PQ1. Then PQ2 2V. Then double that length. Then here this will be Q2. Then Q1R. Here P, Q1, Q2. Then Q1R, it goes like this. We don't know magnitude, but Q1R direction known. Then Q2R direction again known. Here R. 45 degree. Then this will be R point, no? Here previously Q1R due north, now Q1R northwest. Therefore, this intersection will be common R point. Therefore, resultant is PR, no? Resultant is PR. Now, here the resultant. Then according to this, here V, no? Then 45 degree, this will be V. Here this will be root 2V, no? By the Pythagorean theorem, you can get 45 VV. Then here VB root 2V. Root 2V. Then this also surely 45 degree according to that geometry, no? 45. Now here we need to find actual velocity of the wind. Find actual velocity of the wind. Then actual velocity mean with respect to earth, no? With respect to earth. Then here velocity of wind with respect to earth given by the resultant PR. Then here the required one. Here the required one. Then velocity of wind with respect to earth, here 45 root 2V. Root 2V. That is northeast. Northeast direction. Northeast direction. Northeast direction. Okay. Complete. That is 2002 LL question. 2002. LL question, same type question. A boy running due south along a straight road with speed u. Velocity of boy with respect to earth due south u. Phase wind blowing due west. Then velocity of wind to him, that means with respect to boy due west. So due west, here due west. If it is given from west, then it directed east, no? Then here due west. From west, opposite. When he running due north along straight road. Now he gonna run due north with same speed. He feels the wind blowing due southwest. Here southwest. From southwest. Sorry, due southwest. Here it is. Now we have two cases. Here case number 1, case number 2. But we know velocity of wind with respect to this is common. Common. Then write relative velocity theorem. Wm me. Okay. Then Wm, here velocity of Wb, no? Wb Be. Here consider first set. Then second set. Here second set. Then similarly here it is. Now here u. Take PQR notation. Here P, Q, then here Q, R. The resultant is PR. Then take here P, Q, here take Q1, we have two cases now, then Q2, here Q2, R. You practice PQR notation properly, Then start sketching PQ1, here PQ1 and Q2, here P, Q1, PQ2, U, then Q1R, then Q2R, this will be R now. Put directions, the resultant is PR. Then here U, 2U, 45 degree, then here this is 2U, then PR, take angle alpha, PR magnitude, apply Pythagorean theorem, 2U squared plus U square root, and that is root 5U. Then alpha tan inverse U over 2U. Tan inverse 1 over 2. Tan inverse 1 over 2. Okay. Hence find the true speed and direction of the wind. Then here velocity of the wind PR vector. Here PR vector is this. So here true velocity root 5U tan inverse half, no? Root 5U tan inverse half. Okay, then you try 2011 LL question. 2011. Here 45 degree inclination, we know for 45 degree inclination these two sides same, no? 90 degree, no? Then only this is 45. Here now 2U, this will be 2U, 45 because of 45 degree inclination. Okay. Then go to 2011 LL question. Okay, 2011. If you are in doubt, do with me. You practice same questions again and again and get idea. ABC 3 lamp post, topmost point ABC lies on horizontal plane versus equilateral triangle. Side simple A, wind blows in the direction AC. So you better to sketch this way. Here A, B, C. Now wind blowing parallel to AC. Then velocity of wind with respect to earth, that velocity given U. Then velocity of bird whose speed relative to the wind, that is V. So that V value given U, no? Then only he can complete the path. He flies from A to B along AB and B to C along BC. Okay? Along AB, along BC. Now there are two cases. Velocity of bird with respect to earth. Yeah, equilateral triangle, no? 60 degree inclination. Now here we have the data set. It contains only direction known quantity, magnitude only magnitude known quantity, and both magnitude direction known quantity. No? Then you have to subject only direction known quantity first. Subject it. V BE, VBW, VWE. Here we have two cases. Then here V, here U. Then this one change now. Then take only PQ here. Then this will be QR vector, but for two cases PQ won't change. Then R can be changed now. Take 1, 2. Then here PR1, PR2. This notation very important, okay? Notation is very important. Then here PQ, vector start sketching U, QR vector V, then that is given greater than U, no? Then Q center radius V circle. Q center radius V circle. Then PR1, 60-degree inclination. Here this will be R1. Then complete circle, complete triangle, here V. We can find easily by this construction. Here U sin 60, root 3 U over 2. Here this is U cos 60, U cos 60, U over 2. Then you can find PR, no? PR1, apply Pythagorean theorem for this and add U over 2 then. V square plus minus root 3 U over 2 square root plus U over 2. Then we get 4V square minus 3U squared root plus U divided by 2. Here PR1. Then B to C motion PR2. Here take P. Then this is R2. Then we can complete triangle. According to geometry, PR1, PR2 same, no? Here PR1 equal PR2. PR1, PR2 same. Ensure that the total time taken for the journey from A to C through B. Then total time taken, here side A over PR1 plus A over PR2. Both are same, no? Then 2A over PR1 here, 4V square minus 3U squared plus U divided by 2. Then 2 upstairs, 4A, 4V square minus 3U square root plus U. Here the time. 4A over U plus 4V square minus 3U squared. Okay. That 2011 error question. Then we try 2016. 2016. Okay, while you're doing, see this one. While you're doing, see this one. Here ABC light towers, no? Light towers. They are placed on ground. That means ABC point on the earth, no? ABC point on the earth. Then bird moving A to B. Bird moving A to B means with respect to earth, not with respect to wind. No? He moves with velocity. He moves along AB. That means with respect to wind. sorry, with respect to Earth. Here, with respect to Earth. But velocity of bird with respect to wind given. Velocity of bird with respect to wind is given. But here that moves A to B. Then with respect to Earth, velocity direction only given. Okay. Then that's why we take here direction only directed 60-degree inclination. Here 60-degree inclination for BC motion. Here this is for AB motion. This is for BC motion. Okay. Then when you sketch in triangle, you subject direction known quantity first. Direction known quantity, write relative velocity theorem. So PQR notation is the important one. So you take here fully known quantity as PQ. Fully known quantity as PQ. Take this one PQ. Then if this one PQ, this will be QR. The resultant will be PR. Resultant will be PR. But here there are two cases for resultant, no? Two motions, no? Then PQ won't change. This is fixed, no? Velocity of wind with respect to Earth is fixed. Therefore, P won't change, Q won't change. There are two cases. Then R we have to change. That's why we put Rx here. Then X two cases, 1, 2. Here PQ, QR, then resultant PR. Then here take P, here take R, PR1. Then take here P, take here R2, PR2. Then you sketch. So when you are sketching, you sketch general one, okay? You sketch general one. Don't sketch perpendicular to that. You just sketch general one. Then here by symmetry we can see these two same, no? Then according to that general diagram, you need to sketch. Okay, that's how we do. Okay, then 2016 A-level question. A-level question. Here the river ABC points, here A, C, B, it flows with velocity u. Velocity of river with respect to Earth u. A boat moving with velocity v relative to water. Velocity of boat with respect to water or river, v value given greater than u, no? Start off from A and moves until to reach B. Then it moves from B to C. Sketch the velocities. So first we have to take A to B motion. A to B motion. Okay. Then velocity of boat with respect to Earth. AB Earth level. Then here equilateral triangle. One side simple A. Then here 30 to the horizontal now. Then here Earth level. Then with respect to Earth 30-degree inclination. So these 2 points on Earth. Therefore relative to Earth velocity is this. Then by this data set, you better to subject direction known quantity VBE, VBW, VBR, VRE. Here 30-degree, BRV, REU. Then take here PQ vector, here QR vector, here resultant PR. That is PQR notation. We start fully known quantity as PQ. Okay. Now sketch PQ. You know. Then QR is V. then only magnitude known, then possible R points on the circle, Q center, radius, V circle, you sketch. Q center, radius, V circle. Then here possible R points. Possible R points. Now A to B motion to the horizontal 30, R. Here 30-degree inclination. Then complete triangle, put directions properly, PQ, then QRV, and resultant PR. Then we can get the sun by producing this, sketch perpendicular. Then here 30, no? U sin 30 is this. U sin 30 mean U over 2. Apply Pythagorean theorem. Then here PR1. Apply Pythagorean theorem for this. V squared minus U over 2 square root. Then for V square minus U squared, root divided by 2. Then we have to subtract U cos 30. Then PR1. Then take this one. For V square minus U square, root divided by 2 minus U cos 30. Then for V square minus U square root 3U divided by 2. That's the value. Okay, then B to C motion. Then B to C motion this say. Now it look like this. Here R2. Then by this case also we can find that. Here this remaining length, here this length will be PR2, no? Then we have subtracted U cos 30, no? Now we have to add. Then PR2 for V square minus U squared root plus root 3U divided by 2. Likewise we can deduce. We can deduce that, no? Now the total time taken. So here A displacement, then we can take total time. We know displacement and velocities. Then total time A over PR1 plus A over PR2. For V square minus U square root plus root 3U over 2 for V square minus U square root minus root 3. Here minus, first one minus, second one plus. Put 2 upstairs and get common denominator here. For V square minus U square root minus root 3U. Here 4V square minus U square root plus root 3U. Then 4V square minus U square root plus root 3U. 4V square minus U square root minus root 3U. Cancel. Then you can simplify, no? Then here double, no? Then 4A 4V square minus U square root. Then here 4V squared minus U squared 3U squared. Then you can cancel 4V square minus U square root divided by V square minus U square. V square minus U square. Okay, 2019. Check your answers. Here A, B, C, D. A, B, C, D. Velocity of the river U. Velocity of B1 boat with respect to river V. V greater than U. Velocity of B2 with respect to river V. Both V, no? Both V. Okay, then B1 boat move A to C and C to D. Then velocity of B1 with respect to Earth, there are two cases. First one 45 inclination, second one parallel to the bank. B2 with respect to Earth, A to B, B to D. Likewise, altogether there are four cases. Altogether there are four cases. Now B1, B2 velocities same, no? B1, B2 velocities are same. V. Show that the speed of the boat when it's motion from A to C. A to C motion we have to check and find the speed of the boat B2 from B to D. Further show that the boat B1, B2 reach D at the same instant. Okay, now you subject velocity of boat with respect to Earth. That can be B1 or that can be B2, whatever it is, okay. BR, RE. Likewise, here relative velocity theorem. Relative velocity theorem. Now here we have four cases. I write it here. VBE, VBR, VRE. Now here there are four cases. First I get only one. Here V, here U. Then U fixed value PQ. Then here QR vector, there are four cases, put Rx here. X equal 1, 2, 3, 4. Then PR1, PR2. Here PR3, here PR4. A sketch circle. Here PQ vector U, QR vector V. Here radius V circle, sketch it. Center Q, radius V circle. Then PR1, 45 inclination. Complete triangle. Then we better to find this. U over root 2 here. U sin 45, U over root 2. Then apply Pythagorean theorem. Then PR1, apply Pythagorean theorem here. V square minus U over root 2 square root plus U cos 45. Here this technique very simple and very strong method, this one. Huh? Then 2V square minus U squared root plus U divided by root 2. That is PR1. Okay, we have to show that one. Now PR2 upstream, that is V minus U. Then PR4, here this one. Then PR4 we can obtain by PR1. PR4, then same inclination here 45 now. Then you change here minus 2v square minus u square minus u. Then PR3 downstream. PR4, no? PR3. U plus V. These are the velocities. This thing we have to prove, no? Okay, then you find time. B1 boat A to C and C to D. B2 boat A to B and B to D. Then you find total time taken. Find total time taken. Here we need to show they take same time, no? Now here one side AB breadth A, no? Here A root 2A. Then take TB1 root 2A divided by PR1 plus A divided by PR2. Root 2A divided by PR1, 2V square minus u square plus u, root over 2 PR2 V minus u. Then 2A, 2V square minus u square, root plus u, V minus u, then multiply by conjugate here. 2v square minus u square minus u. Then 2v square minus u square minus u square. A, put v plus u here. Then v square minus u square. Then here this will be 2v square minus u square. Then cancel 2. Then we have common denominator, cancel u. Then final result is A V plus 2v square minus u square root divided by v squared minus u squared. Here for B1 boat. Here this time for B1 boat. Okay, similarly you find for B2. Here for B1. Then TB2 A divided by PR3 root 2A divided by PR4 A over V plus U root 2A over 2U square minus V 2V squared minus U. Then multiply by conjugate V plus U 2A plus U here this will be 2 V square minus U square, cancel 2 now. Then V square minus U square, take common denominator A V minus U plus 2V square minus U square root plus U V 2V square minus U square root divided by V square minus U square. Now we see here both times are same, no? Both times are same. TB1, TB2. then they come to point D at same instant, no? Okay. Start 2023 LL question. 2023 LL question. Start. 2023. Okay, 2023. A river simple d meters wide. Here point A, point B, point C. Here D, here D. Speed u. Velocity of river with respect to earth u. A swimmer P whose speed relative to water root 2u. Velocity of P with respect to river root 2u. Direction not given. Start from point A on the other bank here. Here P is here. And he gonna swim directly opposite to the other bank. Then velocity of P with respect to earth directly opposite. Then you write relative velocity theorem. VPE direction known quantity subject. VPR VRE. Root 2u u. Here PQ vector, QR vector, resultant PR. Now start sketching VT velocity triangle. I'll do it here. PQ, that is u, no? Then QR root 2u greater than u. Then center Q, radius root 2u circle. Yep, possible R points. Center Q, okay? To properly mark center, properly get radius. Then PR, need to move perpendicular to the bank, A to B. Here, root 2u. Then PR, root 2u squared minus u square root, that is u. Then time to cross the river. Then time to cross the river for P. Then displacement D divided by PR. Then D over U is the time in seconds. D over U second. Okay. Then velocity of Q relative to water 2 root 2u. 2 root 2u. Start from point C, that means somewhere here. and he gonna meet the simmer P. He gonna meet the simmer P, no? So P is here, Q is here. Then to meet P, relative to P, he has to move along this direction. Here 45-degree inclination, no? 45-degree inclination. You stop P and Q move that way. Then velocity of Q with respect to P, 45-degree inclination. 45-degree inclination. Okay. Then here QR vector, velocity of P with respect to R, with respect to river. Okay. Now subject this one and write relative velocity V QP VQR VRE. Then 45-degree inclination, 2 root 2 U, here U. Okay, now here Q, P, stop at end at P. This is wrong. Then is RP VRE plus VEP. Then river velocity U, here velocity of, we can take this now. We can take fully this one. No? Velocity of P with respect to R. Velocity of P with respect to R. Here its direction. Take angle alpha. Alpha tan inverse 1 over root 2. Now cos inverse. Here alpha equal 45 degree. No? Pi divided by 4. Then here velocity of P with respect to R, that is QR vector. Then we need to get opposite one. Velocity of R with respect to P, opposite direction 45. 45-degree inclination. So that value root 2U. Root 2U. Now we have to sketch another circle. You take here again PQ. Take P1, Q1, then here Q1, R1, here resultant P1, R1. Clearly get that idea. VRP mean velocity of R with respect to P. Here we have velocity of P with respect to R given. So you find that direction, that vector given by QR. Then start sketching that. Okay, then here sketch P1, Q1, 45-degree inclination, P1, Q1, root 2U. I'll mark Q1 here. Then Q1, R1, 2 root 2. Then double distance, center Q1, radius 2 root 2. Sketch circle. Q1 center, radius 2 root 2. Then P1 R1, 45 inclination again. Then here radius 2 root 2. u. Here 90, no? Then you can find P1 R1. Then P1 R1 equal, apply Pythagorean theorem, 2 root 2 square minus, here root 2 u, no? Root 2 u square root. Then here root 6 u. 8 minus 2 root 6 u. Then second case, that case, to catch P, here Q need to meet P, no? Then corresponding displacement here dd root 2d, no? So he has to move root 2d displacement. Then corresponding time, tq time, root 2d divided by velocity root 6u. Then 1 over root 3 d divided by u. 1 over root 3 d divided by u. Now we need to show that the sigma q meet the sigma p before the sigma p reach the point B. Then because of this you can say tq is less than tp, no? Here d divided by u divided by 1 over root 3, no? Then tq less than tp. Therefore q meet p before P reach B. Then Q meet P before P reach B. Okay, that is the thing. That is 2023 question. Okay, 2020. Now here a ship is sailing due west with uniform speed u relative to Earth. Then velocity of ship due west given. Boat is sailing in a straight line path with uniform speed u over 2 relative to Earth. Velocity of boat with respect to Earth u over 2, direction not given. At a certain instant, the ship is at distance d at an angle pi over 3 east of north from the boat. East of north. Here north, here pi divided by 3. Angle east of north. In a certain instant, the ship is at distance simple d east of north from the boat. Here from the boat. Boat ship. Okay. Now, if the boat is sailing relative to Earth in direction making pi over 6 west of north, so that boat can intercept the ship. Now it says that boat can intercept the ship. Therefore, velocity of boat with respect to ship. So it need to move pi divided by 3 angle, no, to intercept the ship. Then VBS, subject the sun and right relative velocity. BES. Here pi by 3 u over 2 opposite direction u. Then take p q, here qr vector, resultant pr. Now that's gonna intercept the ship, here resultant. Then sketch pq vector first. Here pq vector magnitude u. Then u by 2, qr vector u by 2, midpoint here, take center q, radius u over 2 circle. Now here it is. Now first you find this tangential line inclination. This is u by 2 now. Take this angle alpha, here this is u. Then sin alpha, u by 2 over u, it is half. Then alpha pi by 6. Alpha pi by 6. Then we can find r point, no? R. Then same inclination pi by 6, no? Then interception can happen, no? Interception can happen. If this alpha angle greater than pi by 6, then no interception. They can't meet. If this angle less than pi by 6, then they can meet two different cases. We can cut the line now. Now here it touch. That means we can find r point, possible r point. Therefore you can say, therefore B can intercept. We can meet S. B can meet S. If we move pi divided by 6 angle. Okay. Now we need to find the time to intercept. Then PR magnitude. Find PR magnitude by the Pythagorean theorem. U square minus u over 2 square root. Then 4, 3. Root 3 u over 2. Therefore time to meet S. Say T1. T1 here displacement given D, no? Then D divided by PR root 3 u over 2. 2D divided by root 3 u. Here the time to intercept the ship. 2D divided by root 3 u. That's how it is happen first. If the boat is sailing relative to Earth in the direction making pi over 6 east of north. Now another new case given. Velocity of boat with respect to Earth, u divided by 2, pi over 6 east of north. Here pi by 6 east of north. Value u over 2. Show that the here ship with respect to Earth, that is already given, no? U. Then we need to find shortest distance, no? We need to find shortest distance. Then to find shortest distance, we have to find relative velocity. Then I take here velocity of S with respect to B. VSE VEB. Velocity of boat with respect to S. I'll take this one. BEES. Here pi by 6 u over 2. Here u. Then resolve u plus u over 2 cos pi over 3 u over 2 sin pi over 3. Then here 5u over 2 and here root 3u over 4. 5u over 4, no? Half 4, 5. Okay, here it is. Then we can find V1 value, an angle alpha. Let's say angle beta, that is relative velocity. Then V1, apply Pythagoras theorem. Phi u over 4 squared, root 3 u over 4 square root. Then 28, 4 square u square root, root 7 u divided by 2. Here the velocity now. Better to find angle beta. Beta tan inverse root 3 u over 4 divided by 5 u over 4. Now here the angle now. Then we know with respect to ship both velocity, direction and magnitude. We know velocity of B with respect to S. So its magnitude, direction now already known. Then by that one we can find shortest distance. Okay, continue. Step by step identify the thing. Now let's move to displacement diagram. Now boat is here, ship is here, so we know velocity of boat with respect to ship. Here this inclination to the horizontal pi over 6. Then you take angle, consider tan beta value root 3 divided by 5. Then tan pi over 6, 1 over root 3. Then here simplify 3 over 5, 1 over root 3. Then here, therefore you can say beta angle less than 5 over 6. Then because of this value root 3 over 5, multiply by upstairs downstairs by root 3, then 1 over root 3 and fraction of that beta. Therefore beta angle less than 5 over 6. Or you can first write tan beta less than tan pi over 6. Therefore beta less than pi over 6. Therefore relative path goes like this. Relative path. Here locus of B with respect to S. So we have to find the locus. So we don't know exactly beta, no? We don't know exactly beta. That's why we have to think about that, okay? Here angle beta, now here pi by 6. Then here the shortest distance. Shortest distance, here D, here pi over 6 minus beta, resolve. D sine pi over 6 minus beta. D sine pi over 6 cos beta cos pi over 6 sine beta. Here shortest distance. Shortest distance now. Then you find sine beta. Here this is beta, no? Then by that one you can find sine beta, tan beta root 3 over 5. Tan beta root 3 over 5. Okay. Sine beta. Here sine beta value root 3 over 4. Root 3 over 4 divided by root 3 over 4 divided by root 7 over 2. Then root 3 over 7, 2 root 7. Cos beta value, here cos beta value 5u over 4 divided by 7u over 2, root 7. 5 over 2 root 7. Now you can simplify. Find this value now. Sin 30 half, cos beta 5 over 2 root 7, cos 30 root 3 over 2, sin beta root 3 over 2 root 7. Now simplify this. Here d of 4 root 7, denominator 5 minus 3 2, d over 2 root 7. D over 2 root 7 is the shortest displacement now. We have to practice only few things, not many things. Okay, we have to practice only few things. So one is about shortest distance, another thing about meeting another one, then those type of things. Here we have to sketch locus of B with respect to S, then sketch perpendicular, that will be the one. Then by geometry and trigonometry we have to find the corresponding angles and displacements. Okay, complete.